Section 8, question 1. U and V are vectors given by U, which is k cubed 1k plus 2, and V 1 3k squared minus 1. If u dot v equals 1, show that k cubed plus 3k squared minus k minus 3 is equal to 0. So u dot v is a scalar product, so the component forms for the scalar product is that times that plus that times that plus that times that, so we're saying that that's equal to 1. So k cubed times 1 is k cubed, plus 1 times 3k squared is 3k squared, plus k plus 2 times minus 1, and that's equal to 1. So that's k cubed plus 3k squared minus k minus 2, bring the 1 across, minus 1 is equal to 0. So that's k cubed plus 3k squared minus k minus 3, and that's equal to 0. And that's part A. Part B is about polynomials. So that says show that k plus 3 is a factor and hence factorised fully. So if k plus 3 is a factor, minus 3 goes up at the side. The coefficients are 1, 3, minus 1 and minus 3. Drop the 1 down. 1 times minus 3 is minus 3. 3 minus 3 is nothing. Times that by minus 3 is minus is still nothing. 0 minus 1 is minus 1. Times that by minus 3 and that's 3. So r equals 0. Therefore x plus 3 is a factor. So I'm backing up with a statement since it's a show that question. The question then says factorise fully. So I've got x plus 3 bracket x squared plus 0x minus 1, just minus 1 then. So it's x plus 3 and difference to squares will give me x plus 1 bracket x minus 1, and that's factorised fully. That's part B. Part C says deduce the only possible value of k. I'm just going to tidy up a wee mistake here. So where I've written x, that really should be k. So that's k plus 3 bracket k plus 1 bracket k minus 1. So that'll give me 3 solutions, which are k equals minus 3, k equals minus 1, and k equals 1. If I go back to the question, it does say that k must be greater than 0. So if I go back to the 3 solutions, I discard that one, and that must be the final answer, k equals 1. Part D says then, the angle between u and v is theta, find the exact value of cos theta. So if k is equal to 1, then we know that vector u can now be written as 1 cubed, which is 1, 1, and k plus 2 will be 3. For vector v, we've got 1, remember k is equal to 1, so 3k squared will be 3 minus 1. So my two vectors are u113 and v13 minus 1. Cos theta, now got the formula list and use the scalar product formula, so u dot v over magnitude u magnitude v. So u dot v is 1 times 1 plus 1 times 3 plus 3 times minus 1. And added together that's 1. For magnitude u, that's the square root of 1 squared plus 1 squared plus 3 squared, and that's the square root of 11. For magnitude v, that's the square root of 1 squared plus 3 squared plus minus 1 squared, which is also root 11, so I'll put both of them down there. So root 11 times root 11 is 11, so I've now got cos theta is equal to 1 over 11. And that's the final answer to the question. Section 8, question 2. Vectors A and C are represented by two sides of an equilateral triangle with sides of length 3 units. So I'm just going to put that in just now. As shown in the diagram, vector B is 2 units long and B is perpendicular to both A and C. Evaluate A dot A plus B plus C. Well, that's just A dot A plus A dot B plus A dot C. So I'm just going to take each one of them in hand. So A dot A is just equal to the magnitude of A squared. So we know that to be true. So that's just 3 squared, which is 9. And they're going to look at A dot B. Well, A dot B, remember that the scalar product of two vectors when they're at right angles is 0, so A dot B is equal to 0. Next one I'm going to look at is A dot C. So it's an equilateral triangle, so the angle in here must be 60 degrees. So A dot C is magnitude A, magnitude C times cos theta, and the magnitude of A is 3 times magnitude of C, which is 3 times cos 60. So that's 9 times 1/2, that's 9 over 2. So final answer to the question is 9 plus 0 plus 9 over 2, and that's 13.5, and that's the final answer to the question.